Okay, welcome Ananya. I see you're here. So thank well done. Let's get to work, okay? Let's get to work, Ananya. So what we are going to be talking about, we are going to be continuing with what we talked about in the first part of the transformations of functions. We did not finish, and then we'll get to questions, right? To see how it goes. So in transformations of functions, we know that we were saying here we are transforming a function. We are not transforming a shape. In the first part of your at IGCSE level, when you did the 4 transformations, you were transforming shapes. So you'd get a triangle or some other shape, and you needed to transform it. I'll show you some of those questions. Here we are not doing that. We'll be transforming a graph, something about a graph. So we'll go and see those questions, right? But we'll be transforming a graph, and either it will be a shift or a stretch or a reflection. And we said now that it could be horizontal or it could be vertical. Oh, I can't believe that we only talked about horizontal in our last lesson. So let's continue. Here we'll talk about reflection, and we'll start off with horizontal reflection, right? That's the last type of transformation that we hadn't talked about. So in reflection, I just want you to know that it will be when you multiply by -1. So in other words, the sign changes, okay? In brackets, just say the sign changes. The sign of what? Either the sign of the whole thing or just the sign of the x part is the one that is going to change. So something, the sign will change in some way. Give me a second to fix this. I want you to be able to see the whole board. All right, so here we are saying the sign changes. So you multiply by -1. If you multiply by -1, if the sign changes, then this is going to be a reflection. A translation, you add or subtract. I want you to watch the part 1 for those who didn't watch transformations of functions part 1. I'll put the link in the I'll put it in the video link, okay? In the description of the video. I'll put the link in the description of this after I post it. So you go to live videos on my channel. On this channel, you go to live videos. You see A-level maths transformations part 1. Here we are doing transformations part 2. So what we are saying now is the last type of transformation that we hadn't done was reflection, where you multiply by a -1. So the original curve will be, the original one will be y equal to f of x. Now the one that you get after transforming is now you have y equal to f of -x. So wherever there is x, you see that the sign has changed. You see that the sign has changed wherever there was x. That will be proof to you that this is a reflection. And if it's changing right where there is x only, if it's changing right where there is x only, it will be the horizontal version of reflection. Remember that reflection, you'll be changing either inside or outside. So I'm about to go and show you vertical transformations as well. But I'm saying when things change by a negative, that is going to be a reflection. So for example, if the original was e.g., okay, example, if the original function was you have y equal to maybe x squared minus 5x plus 2, if you now have something which goes like this, y is equal to negative of x squared, okay, then we say here minus 5x could become plus 5x, okay? Then we could have it plus 2 here, plus 2. Wherever there is x, we are changing, okay? If we say y is equal to, for example, let's say the negative is inside. It's negative of x, then o squared. Then it's minus 5 by negative x, which will obviously become plus 5x, then plus 2. So wherever there was x, we know that this negative of xo squared will eventually just stay as an x squared. But the fact that there was a negative inside, and here we have this negative, this means that everywhere where there was x, everywhere where there is x, we are changing to a negative x. So this is definitely a reflection. Reflection just changes the sign. So once we see a sign change, it's a reflection. all we need to do is the sign change also affecting the constant? If the constant is not affected, that means this sign change is exactly where x is. It's only affecting exactly where x is, so that is a horizontal one. Horizontal only affects exactly where x is. So let's talk about all three transformations being vertical now, because we did not talk about the vertical version. Okay, we want to talk about vertical transformations. The vertical transformations. Remember, we have three types of transformations. We are transforming functions, not shapes anymore. So that's a lot, you guys. I'm happy you know that. And we have the three, which is going to be shift, which was the same as translation. Then we have stretch, which is the same as enlargement. You can make something smaller. You can stretch it to make it smaller, or stretch it to make it longer, or whatever. Or stretch it to make it taller, when it stretches up and down, or stretches to the right and forward, or whatever. Then lastly, you are going to have reflection. So these are the three transformations: shift, stretch, reflection. Shift, stretch, reflection. These are the three transformations. So what would you have? Remember, the original is we have y equal to f of x. After a shift, if it's a vertical shift, you would have now, remember, shift, you are going to add or subtract. You add or subtract something. So a constant, you add or subtract. So if you now have y be equal to f of x, then you add at the end. I want you to know that everything which is vertical will do it at the end. Okay? If you are multiplying outside everything, outside the f of x. If you are adding outside the f of x. If you're subtracting outside the f of x, not right where x is. Whatever you're doing outside. That makes it vertical. Because for stretch, you'll be multiplying as well. Everybody now knows that. For stretch, we multiply. But here, you'll be having, this is the original one. Y is equal to f of x. Okay? For stretch, remember, you multiply or divide by a constant, right? You multiply or divide by a constant. So if this was the original one, after a stretch, you'd have it now say y is equal to a times f of x. So we have multiplied the whole function by a value. Everything that was in the function, including the things that we're adding, has been multiplied. In here, the only thing that was multiplied or divided by was the x itself. So the constants have not changed. The -9 is still a -9. In here, constants don't change for horizontal stretch. It only multiplies the x right where x is. Horizontal is right where x is, right where x is. So if it's a shift, it will only add right where x is. So wherever there was an x, now you are seeing an x plus a. So where there was an x, you see an x plus 3. Where there was an x, you see an x plus 3. Exactly just on x. But the constants are not affected. The constants are not affected. You are adding or subtracting. So it's a shift. Shift, you add or subtract. But remember, the shift could be horizontal, so the shift could be vertical. So don't just say shift. It's not enough. Which one? Give me a second. I've got something on my throat. Okay? Good. So, first of all, we have to see that it's a shift. Then we look, is it right where x is? Anything which is right where x is horizontal. You're subtracting right where x is. So that is horizontal. Shift. You're adding outside. So you let the whole function come back as it was. Then at the end, you add or subtract something. So you see the constant changing value. That's a shift. Here, you multiply outside. So you're multiplying everything. So everything will change value. Even the constants, yes, will be multiplied because you're multiplying outside the whole thing. So you're multiplying the whole thing, not just where x is, or dividing the whole thing. So it's a stretch, and it's a vertical one. And when we describe it, you describe exactly what you are seeing. You are going to say stretch. Here you say stretch by factor A. Okay? you say vertical stretch. Vertical doesn't lie. We said horizontal lies. So here you would say vertical stretch by factor A. The guy that you multiplied by. What did we multiply by? We multiplied by A. So it's a vertical stretch by factor A. Okay? In here, you say this is, we have added outside. So this is going to be a vertical shift. You say this is going to be a vertical shift by A units. Then we say, is it up or down? Because if it's vertical, either to go up or to go down. So since it's a positive A, it will be up. So vertical doesn't lie. For horizontal, when we see a positive A, we know we are actually going to the left. It's a liar. So don't let it catch you. We know that when we see A multiplying in horizontal, when it's in the inside, horizontal is a lie. When A is multiplying, we say our scale factor will actually say 1 over A, even though it was A. But when we describe, we say 1 over A to get it correct, because that's horizontal. It's a liar. So for reflection, you would have y equal to negative f of x. That means everything will change sign, including the constant. The negative is affecting the whole thing. So the original one was y equal to f of x. After the the reflection, it becomes y equal to negative f of x. This is after a reflection. So you are going to say here, reflection in the x-axis. That means it's a vertical reflection. A horizontal reflection here, you'd say reflection in the y-axis. That's another one where people make mistakes. A horizontal reflection, the y-axis is the mirror line. We move from one side of the y-axis, we go to the other side of the y-axis. That means we have moved horizontally. So our mirror line is the y. So we say reflection in the y. That means we are moving horizontally. Why? Because it's the x that had changed values. So you need to see a lot of questions until you get good. Then here for reflection in the x-axis means it is a vertical reflection. If you want, you can write vertical reflection. It's a vertical reflection and you'd be done. You don't have to specify too much. So this is it for the transformations. Let's try to see some questions. So I'm going to load some questions. So give me 1 second. Okay, I'm going to load a question. Let me load a question. I've loaded the first paper. Let's see if we have transformations here. There we go. Describe fully the sequence of transformations that have been combined, making clear the order in which the transformations have been applied. Okay, let's just see the transformations, okay? That's not even a problem. Let's see which transformations are here. The fact that x has changed to x minus 3. That means here we can already see that there is a horizontal. It's horizontal because x itself has been affected. So this is horizontal. And what is it? Shift. Remember, the original one is this. It was an x. Now it is an x minus 3 all squared. So that means it's a horizontal shift. You know, when you add or minus, right? Remember, we look at everything that is affecting right where x is. Not outside. If you are affecting outside the bracket, this and this are going to be vertical. They are going to be vertical, these ones, because they are right where they are outside. Let's talk about it. So what are we going to say here? Would say, they say describe fully the sequence of transformations, that making clear the order. So anyway, we see this. Okay, I'll explain something that I needed to explain, which is like a small mistake here, which can actually catch anyone. So this one, I want you to, everybody agrees with me that this is a horizontal shift. When you add or subtract, it's a shift, right? And when you do it inside the bracket, right where x is, it's horizontal. So this is a horizontal shift. Okay, now when it's horizontal, remember, you should always lie. So it's going to be by 3 units to the right. Okay, although it was a subtraction, we actually go to the right. 3 units to the right. All right, so this is a transformation which is happening. We have this minus 8 which is happening outside. It's another subtraction, so it's a shift. Any addition or subtraction is a shift. So you are doing this with a pencil. Horizontal shift. Okay, then you now say by 80. Oh, it's a vertical shift, I mean. Okay, it's vertical because it's outside. When you add or subtract, it's a shift. So this is a vertical shift by 8 units downwards. Vertical does not lie. So this is actually downwards. Do not forget. This is actually downwards. Okay, so now we are at the last one, which is going to be the last one, the last trick that I need everybody to know. Now, let me say something about when the transformations are combined. I want you to know that one more thing that we said horizontal lies in everything he does. So when you have more than one horizontal, right? When you have vertical transformations and you want to describe them in their correct order, you follow bid mass. Okay, you follow bid mass. This is the order of operations. So you start with the things that are in brackets, right? Then you have powers. Okay, brackets, indices. Then now look at what it says. Division, multiplication, then addition and subtraction. So basically, let me say this. When you are doing horizontal transformations and you have more than one, let's start with vertical. When you're doing vertical transformations and you have more than one, you start with the transformations that multiply or divide. And what are those? Okay, the order doesn't matter, but you start with those ones. That is, you should start with reflection, mentioning, reflection, and stretch. Then when you are done with all the vertical reflections and stretch, you go to the vertical shifts. So remember, we talk about things in order. It doesn't matter if you start talking about the vertical ones, then you go to the horizontal ones, or you start with the horizontal ones, then you go to the vertical ones. That doesn't matter. But as long as you are talking about vertical and another vertical, as long as you are talking about, you want to talk about vertical and you have more than one vertical, put this order. Now, if you are talking about horizontal and you have more than one, you do reverse of bid mass. It's a liar. So you start with shift. Then you do reflection, and stretch. Then you do reflection and stretch for horizontal. So everybody, can you put this down? Can you all put this down, everybody? Can you put this down? It's going to be vice versa. Okay, it's going to be vice versa. So you must have this. That's so important, right? Well done. So now, what we'll be doing now is, okay, let's say we are now at the last one. So when we're describing, you've seen the order. When you are doing for vertical, do bid mass. So start with the things that multiply, which is reflection and stretch. They multiply, right? But they multiply. If it's vertical, then you do the shifts. Now you go to horizontal. You start talking about the horizontal transformations. When you talk about the horizontal transformations, you start with the shift. After you are done with the shift, then what do you go to? You go to the reflection or whatever, right? Okay, so here we now come here. Let's say what happened. We said this 4 is going to be a multiplying. So it's a vertical one, right? What do you say? Vertical stretch. Vertical stretch. By stretch factor, you can call it the factor or the stretch factor 4. Why is it by stretch factor 4? Because it is the 4 that is multiplying. When it's vertical, remember, you put it exactly. If it was inside, if you had multiplied x, if you had seen x being now a 4x, That means we are multiplying inside right where x is. It would have been a horizontal stretch. And would say by factor 1/4. Horizontal does that. So anyway, now let's put the thing. Okay? Now let's put the thing in the correct order. Let's put the things in the correct order. We have vertical shift, vertical stretch. So let's start with talking about the vertical ones. Remember, when you do vertical, stretch comes before shift. So you're going to say vertical stretch. Vertical stretch. You put in the correct order. You say vertical stretch by stretch. You talk about the stretch factor by stretch factor 4. Then next, you're going to say translation or shift. This is a shift. Okay? So you can say translation or shift. I am not interested in that. You can put it whatever you say. So let's just say translation. Shift is a translation when things is moving, just moving up and down. Translation by, let's say vertical translation. Vertical translation. Vertical translation. Vertical translation by vector. You can say by vector. By vector. You can now put how many? We put 3 units downwards or 8 units. It 8 units downward. So by vector 0 minus 8, which is 8 units downwards. Then lastly, you put horizontal translation. Horizontal translation by vector 3. It's 3 in the horizontal, right? Remember, vectors are x then y. So since it's horizontal, it's by vectors. It's shift 3 units to the right. So if we're going to the right, it will be 3, 0. Okay, although it was a minus 3, we are going to the right. So when you put the vector, you say 3, 0. You do that, you lie. That's how horizontal is. It's a liar. This is how you do, and you are done. You get your marks. This is how you do it, and you're done. You get your marks. I'm going to give you some questions that I want you to try. Try these questions, then send, and I'm going to mark. Do you hear me? In the correct order. So this is going to be how you put the transformations, and you'd be done. Okay, everybody. Thank you for attending. Let me send you the questions you get to work. Remind me in the group, okay? Goodbye for now.